Hello everyone. I welcome you all to the basic histopathology course once again, and this is the second lecture of the basic histopathology, and in this the main area of focus is going to be the basics of histopathology. So this is going to be our first milestone that we'll be achieving in the department. Once we are aware of the various things in the department and how the machinery works, now we are going to look into the slides and we will see certain things that are present on every slide. So these are going to be our basics of histopathology, and these we'll be seeing in all slides that we'll be examining. So let us move ahead and achieve our first milestone. So the first thing that you'll be seeing in most of the slides is the types of the epithelium. So all different tissues will be lined by different types of epithelium, and these epitheliums have been typed on the basis of the shape that they are composed of. Like if you have a flattened epithelium, it is called as a squamous epithelium. If it is of cube shape, then it is called cuboidal epithelium. If it is columnar shape, then it is called columnar epithelium. And when the epithelium is intermediate between that of flattened and columnar, then it is known as transitional epithelium, and this transitional epithelium is also known as urothelium, and it is basically confined to the urogenital organs. Now, any of these epithelium, that is a squamous, cuboidal, columnar, or columnar epithelium, they could be of three types. They could be simple, they could be stratified, or they could be pseudo-stratified. So we all know from our from the basic knowledge of MBBS, pseudo means false. That means they're not truly stratified, but they only appears to be stratified. Simple is when you have only single lining of the epithelium, like we see here. So there is just single lining of the epithelial cells which are lying on the basement membrane. Stratified is when you have multiple linings of the epithelial cells, like we could see here. So there are multiple linings and we call it stratified. And pseudo is when we have single lining, but on histology there appears to be multiple lines. So this is called pseudo-stratified epithelium. Now, based on the shapes as we had discussed, we call them squamous, cuboidal, or columnar, and they have specific role in the different areas of the body. So now let's first move on to the simple epithelium. Simple epithelium, especially the simple squamous epithelium, it is the flattened epithelium, and it is being named after the appearance of the fish scales that they have. So they are flattened lining, and that is why they are called as squamous. And this is a simple squamous epithelium which is lining the mesothelial. So this is also called as mesothelial layer, and this is single flattened cells which are lining the mesothelium layer, and this is mesothelial cells. So mesothelial cells, endothelial cells, like we see here on the walls of the blood vessels. So these endothelial cells, they are also simple squamous epithelium. So these are the first types of squamous epithelium, and these are simple squamous epithelium. The next type is the stratified type, which we all see in the skin histology. So when you have multiple layers of the squamous epithelium, then we call it stratified squamous epithelium. So as we see here, so there are many layers of the squamous epithelial cells from base to upwards. Now the important thing that we see here is, if you see, look at the base, it is more blue as opposed to the upper layers which are more eosinophilic in color. The reason is that the basal layer, they are also called the basaloid layer, and it is the regenerative layer. So from here the cells are being dividing and they are going upward. So these cells, they have more ribosomes, and therefore they appear more bluish in color as opposed to the top layer which are more eosinophilic, which have more mitochondria. Now, next thing that we see on the squamous epithelium, and which will become very important whenever you see any histology and you want to tell whether this is a squamous cell carcinoma or it is some other forms of carcinoma. So another very important feature of squamous epithelium are these intercellular bridges. So the cells of the squamous epithelium, they are attached to each other by means of these intercellular bridges, like we see here, and these are also called the prickle layer, that through which one cell is attached to the other layer. So they are coherent and they are cohesive, and that is what we are looking for when we are seeing the cases of carcinoma. The other thing that we see in squamous epithelium is the keratin on the surface, like you see here. So this is again an important feature, and if we see keratinization, then we call it as a squamous cell carcinoma. So this is the importance of knowing the types of epithelium, so that you can identify them on the histology, and you can identify from which type of epithelium which tumor is arising. So the next epithelium that we talked of is the cuboidal epithelium, and as I said, the cuboidal has come from the name, that is of a cube, and as you see here, the length and the breadth of these cells are almost equal. So the base, if you see this length and the length and the breadth, they're the same and they appear as if they're a cube, so they are called as cuboidal epithelium. And this kind of an epithelium we see in different organs, like in breast, like in kidney, and in different salivary ducts. So these are the common epithelium when we see. So if they are in the form of a cube, we call it as a cuboidal epithelium. The next, like we said, the one which is assuming the shape of a column. So when the length is more than the breadth. So here if you see, the breadth is less and the length is more. So when the length is more, then we call it as a columnar epithelium, and then this column is going to be known as columnar epithelium. Now the another important feature that we should be aware of at this point of time is, whenever we are seeing any cuboidal and more so a columnar epithelium, there is this thing called polarization. And this is a beautiful polarization where you see that all the nuclei, so if you look at these nuclei, all the nuclei, they are aligned at the basal layer of the epithelium. So when we see such kind of an arrangement, when all the nuclei are properly aligned in a rack like fashion and they are being adherent to the basement membrane, so then we call it as a polarization of the nuclei, and they are showing maintained polarization. Whereas if you see the nuclei going upward haywire, then we call that this is a loss of polarization. And once we say loss of polarization, means we are talking of something dysplastic. So this is a columnar epithelium. Again, this is a pseudostratified columnar epithelium where you see several nuclei, but actually these are the single cell lined epithelium. Then the next type of epithelium that we see, and especially in the case of urogenital organs, and that is the transitional epithelium. So this transitional epithelium is thought to be intermediate between the squamous and the columnar epithelium. So when the bladder is flattened, you see a flattened layer of lining, and they resemble that of a squamous cell. Whereas when the bladder when it is distended, then the epithelial cell, they assume a columnar position, and then they look more like a columnar cells. The classical feature of this kind of an epithelium is that they are stratified. So you see that there are multiple layers of cell, and normally the layering of cell is usually 6 to 8 layers thick. So it is generally not more than 8 layers thick, and if you see more thickening, then we think of some papillomas, then we think of some dysplasias. So again, the polarization, as I said, like you see the nuclei which are aligned to the basement membrane, and second thing is the number of layers that we see lining the urothelium. Now if you look carefully here, the top layer is almost flattened and the bottom layer, they're more columnar. So this is also a feature of transitional epithelium, where these are called as umbrella cells, where they're the flattened cells, and if you go down, you see the columnar appearance of the cells. So this again we'll be discussing more when we'll be discussing the urogenital part. Now this is the epithelial structures, and they're called epithelial because they're epi means outside. So anything which is in contact with the outer surface, then it is being called as, and most of the things which are covering those areas which are in contact to the external environment, those are being called as epithelial structures. Now we have seen that there are different kinds of epithelium. We have seen the squamous, cuboidal and columnar epithelium. Now we know that the squamous epithelium is the most vast type of epithelium that we see throughout our body, and it is the most resistant epithelium. So it does not allow anything to pass easily through it, and that is why it is being protective to our skin. So now once we know that any kind of histology slides, anything that we are going to get will be covered by some part on the luminal, on the external part by the epithelium. Now beneath this epithelium, we have a good support of the connective tissue. This connective tissue is basically a supportive tissue. So in the normal epithelium that we have seen, we do not see any blood vessel or any neurovascular bundle here. So in all epithelium, they are devoid of any blood vessel or any nerve neurovascular bundles. So from where they are going to get the nourishment? They are going to get the nourishment from the connective tissue which is beneath the epithelium. So this is the connective tissue, and from here this epithelium is going to be nurtured in way of blood supply and through the neural part. So now next thing is, like we said, that in all epithelium, below the epithelium we have the connective tissue. Now this connective tissue again is made up of two things. One is the matrix that we see there, and another thing is the cells that is constituent of the connective tissue. The cells can be fixed cell or they can be unfixed cells. The fixed cells are the fibrocytes, chondrocytes, osteocytes, and the unfixed cells could be mast cells, macrophages, or plasma cells. So whenever we see any connective tissue in the dermis or in the lamina propria or in the subepithelial region, so we see a good proportion, some scanty scattered mast cells, some macrophages, some plasma cells, and in addition we see certain cells which are specific to this connective tissue, and these are the fibrocytes. Now the next thing that in the connective tissue we will see in the matrix are the different kind of fibers. These fibers again are also very important, and there are three main types of fibers that we see. One is the collagen fibers, elastin fibers, and the reticulin fibers. Now it is important to know the different types of fibers, because when we will be discussing the pathologies, when we'll be discussing about the fibrosis, when we'll be discussing the arterial pathologies, then it is very important to understand these fibers, their presence, where they are located, and how they could be affected. Then finally in the matrix we have the ground substance, which is the mucin pools, myxoid pools, or the loose myxomatous tissue. So these are the things which are going to constitute the connective tissue, which will be seen beneath any epithelial structure. So before we go further, let us first understand the different types of fibers that we see in the connective tissue. So basically there are three main types of fibers, as I said. One is collagen, elastin, or reticulin. But the main function of any of these fibers is to give support, is to give strength to the tissue that we are looking at. So all the epithelium that is there and that is intact on the surface is being supported through these fibers which are present in the subepithelial region. So the first one is the collagen fiber. These are the most abundant. They are present throughout the body. They are for strength. So when these are present, that means they are going to give some strength to the tissue in which they are present. Elastin fibers, as the name signifies, it will give elasticity, and it is like a rubber band. So the thing which contain elastin could be stretched for some distance and then it will come back to normal. The reticulin fiber, these are the thinnest fibers. So the thickest one are the collagen. Then number two will be the elastin, and the thinnest fiber that is not visible on the naked eye. So when you see on a usual H&E stain, these reticulin fibers will not be visible, and they will require special stains to see them. So these reticulin fibers are the thinnest of these, and they are only to support the tissue where you have a predominance of parenchymal cells. So when you do not have a connective tissue stroma significant and you have a tissue which is full of parenchymal cells, in those areas you will require reticulin to support those parenchymal cells, and so that they do not fall apart and they do not fall onto some of the surface. So there you will require the presence of reticulin fibers. The organs where you will require collagen, so we know that all skin in the dermis it is present, it is almost present everywhere in the body. Elastin fibers, they are present specifically in the skin and in the arterial wall. The reticulin fibers, they are present in the organs where you have lot of parenchymal cells, that is hepatocytes or the acinous cells. So you see retic framework over there. So spatial stains, for collagen you require Mason's trichome stain. For elastin, you require VVG stain, but they are also visible on reticulin and all silver staining. But the reticulin fibers will be visible only on reticulin stain and the silver impregnated stains. Now we said that they are wavy, they run in bundles. Elastin fibers will be less wavy, and reticulin are the thinnest fibers. So the most difficult to see on the slide are the reticulin fibers. Now let's see an example. So this is a histology of a skin, and what do we see here? We see the epidermis, that is the squamous epithelium, which is lying on the basement membrane. You do not see any vessels within the epithelium, whereas you see a good amount of connective tissue stroma beneath the epithelium. Now this connective tissue stroma is the one which is going to constitute the connective tissue, and it is going to constitute the connective tissue of the dermis. Now if you look carefully, now this connective tissue is made up of some dark eosinophilic fibers, which are these wavy fibers, and some lightly eosinophilic fibers, which are these fibers. So actually this is a combination of collagen and elastin. So these dark eosinophilic thing, they are the elastin fibers, and these broad wavy fibers are the collagen fibers. Now there should be something to produce these elastin and collagen fibers. So they are not just come on their own, they require some cells to produce them. And what are those cells? Those cells are these fibrocytes. So they are being produced by the fibrocytes, and these are the small spindle cells that we see here, and these are the cells that are producing this collagen as well as these elastin fibers. Now in this supporting meshwork, you see that there are presence of blood vessels which are seen here, and these blood vessels are being supported by the collagen and the elastin tissue fibers which are present in the dermis. So even on an H&E, even on your histology routine stain, you will be able to identify elastin fibers and the collagen fibers. Then if you want to confirm the type of fibers, you can go ahead with your spatial stains, and then you can confirm and type the different types of fibers. Now again, if you see here, now this area is showing you a lot of eosinophilic bands, and you see very scantily, sparsely scattered these cells. So if you look carefully, these are again all collagen fibers, and this is more areas of fibrosis. So when there is more of collagen fiber, then we say it is fibrosis, and when the collagen fibers become very dense and the tissue becomes hard, then we call it sclerosis. So it is just one and the same terminology. It is only on the appearance that we are saying sclerosis when it is becoming hard, and when we fibrosis when we are seeing a increased amount of collagen fibers. So this is again an area of fibrosis where you see increased collagen fibers. You do see fibrocytes here, that is the fibroblast and fibrocytes, and these fibrocytes are producing this collagen fibers. In addition, you are also seeing some cells, so these could be some mast cells and some plasma cells and lymphocytes here. So these are the floating cells, these are the unfixed cells in the connective tissue that we said, and these are going to be fixed cells, that is the fibrocytes which are producing these collagen fibers. Now again, another area where if you compare it with the previous one, so this is looking more dense, it is looking more dense and it is showing more of collagen. But if you look at a matrix like this, again this is also a connective tissue stroma, but here instead of being more pink, it is looking like a bluish hue to this pinkish cytoplasm. So this is looking more eosinophilic, whereas if we see on this appearance, it is showing a more bluish hue. But again in this you see these cells which are scattered in this bluish mucomyxoid type of a matrix. So when the matrix is being produced in the soft tissue, it is called as myxomatous matrix, and this myxomatous matrix is distinct from what we saw in the mucin in the epithelial cells. So if you see a bluish hue in a connective tissue, you should think of a mucomyxoid change, and again this is being produced by the fibrocytes which are seen scattered here. So now the third type of fibers, like we said, is the reticulin fiber, and for the organs like a liver, in which you see the organ that is being composed entirely of the parenchymal cells like the hepatocytes. So these hepatocytes, they need some framework. Otherwise, if there is no framework to these cells, they are just going to fall apart and they will not be in place, and you will not see this linear arrays that is beautifully seen in the liver cell. So all these liver cells, they are being supported by a meshwork which is called as reticulin fiber, and since they are very thin, it is not easy to identify them on the histological sections. So you need to do spatial stains, and what spatial stains you are going to do? You are going to do a reticulin stain. So on doing a reticulin, you can beautifully identify these thin reticulin fibers which are surrounding the liver cell plates, and then you will be able to identify the architecture of the hepatocytes more beautifully. Now the next thing that you do for the collagen fibers, so we know that you do a reticulin stain for the reticulin fibers. Now for the collagen fibers, we do a Mason's trichome stain, and this is a Mason's trichome stain which is showing dense collagen fiber deposition in the dermis. Now for the elastin fibers, which I said are present in the arteries, you can do either an Orcine stain or a VVG stain, and the reticulin will also show positivity on the elastin fibers. And these are the internal elastic lamina which is showing a beautiful blackish color on the Orcine stain. So if you want to see the elastin fibers, like I said, they are always present on the arteries, and they are going to make the arteries more pliable. So if the blood is flowing through them, they are going to distend, but if the blood is out from the arteries, they are going to collapse. So this elasticity of the arteries is coming from these elastic fibers, in addition to these smooth muscle cells that we have here. And it is not just the internal elastic lamina which is more strongly positive with the elastin fibers. You also see these thinly scattered elastin fibers in the muscle layer. So they are present throughout the muscle layer as well as on the internal elastic lamina. So again, we said like this kind of a matrix where you see a lot of bluish hue and mucinous hue. So we call it as a mucomyxoid matrix that we see in the connective tissue stroma, and these are all the fibrocytes which are seen scattered in the stroma. So in areas where you see mucomyxomatous area, the fibrocytes, they assume a different kind of a shape, of which we'll be talking later, and instead of a spindle shape, they sometimes assume a stellate shape, or you can say a star shaped appearance, and then they're known as stellate shaped cells. So again, an area where you see a good chicken wire kind of a network of vascular channels, and these are all mucomyxomatous areas. And in these mucomyxomatous areas, there are different types of fibrocytes which will assume the shape of a stellate shells. So this is again a mucomyxomatous background with a rich vascularized network. So now I will maybe we can discuss this. So this is again a fibrocyte, and if you see, these are distinct from the cells which are seen here, and we'll have more images later. So these are all the muscle cells. So once we know that any tissue is being composed of epithelium, it is being supported by the connective tissue. This connective tissue is going to nourish the epithelium, and it is going to hold all the blood vessel and the neural channels, and it is going to supply the epithelium in whatever nourishment it needs. So this connective tissue framework is important for the support. It is going to make the place stay as it is, that is there on the epithelium, and it should not fall apart. So that is the role of the epithelium and connective tissue, and in any histology slide that we will see, we are going to see these two structures. Now the next thing is, when we know that we are already aware of the epithelium and the connective tissue, the second thing that comes is what type of cellular details are we looking at. So especially you will not see pathology from the normal organs. What you will be seeing is the pathology from the abnormal organs, and in those organs you should be able to identify what type of cell you are seeing, how is the cell behaving, whether it is behaving in a benign fashion or in a malignant fashion, how is the cytoplasm. So based on the appearance of nucleus and cytoplasm of these cells, we are going to define the cell types, and then we are going to put them into various categories. So let's see how we are going to define the cell types. So we already said that we had different types of epithelial cells, and these epithelial cells, based on their structure, they could be cuboidal, columnar, and then there could be some specialized epithelial cells, like we have this cell which is polygonal shape and a round vesicular nuclei. So otherwise you have cells which are like elongated and spindly in shape, then they are known as spindle shaped cells. And sometimes you have these cells which contain scanty cytoplasm, they have no cohesion with each other, and these kind of cells are known as lymphoid cells. So by looking at them, you can tell that this is a lymphoid cell population. And how do you know that? They are all discohesive. So there is no cohesion in the lymphoid cells. They all fall apart, and there is no framework, and they are all separated from each other by a good space. So that is the characteristics of the lymphoid tissue. So when we have seen the shapes of the cells, whether it could be cuboidal, columnar, polygonal, then it could be spindly shaped, or it could be lymphoid in nature. And then there are certain specific types of cells like the melanomas, which could assume any shape, any of these shapes. So they are also called the mimickers. The melanomas are also known as mimickers because they can take the shape of any type of epithelial or mesenchymal cells. Now once we have identified the type of cell that is present in the slide, so next thing to look for is the nuclear features. So most important thing is how the nucleus is looking. Is the nucleus looking benign, or it is showing you some change which can put it into a malignant category. So now if you look here, this is a beautiful slide which is showing a plasma cell. Now these plasma cells, if you look at the nuclei, the plasma cell nuclei, they have got a cartwheel appearance, and these are dark areas which are called the heterochromatin, and in between you have lighter areas which is called the euchromatin. So these darker areas which is called heterochromatin, they are less active areas of the nucleus, whereas this euchromatin is a rapidly active area and where a lot of RNA synthesis is going on. So in a plasma cell we have distinct areas which are called heterochromatin and euchromatin. Now suppose in a cell you have a nucleus which is filled completely of heterochromatin, which is completely dark and hypochromatic, then we call that cell as a hypochromatic cell. And if you have a cell which is composed mainly of euchromatin, so it will look vesicular, and then we call it as a vesicular cell. So this is a classical cell in which you can see the beautiful areas of the nucleus as heterochromatin and euchromatin, that is dark and light areas. Now let us look at some of these nuclei. So if we look at this nuclei, if you compare it with the plasma cell, it is not at all showing you any dark areas, rather it is all lightly stained. But in addition, you are also seeing a prominent and big eosinophilic nucleoli. So this cell is going to be called as a vesicular nuclei, wherein the nuclear details are very finely scattered. You see many vesicles, many light colored areas within the nucleoli, and most of these vesicular nuclei, they will be accompanied by a prominent nucleoli. So in any histology, when you're talking of a vesicular nuclei, you are telling that this is a very rapidly dividing cell. As I said, that euchromatin is the area where this lot of activity is going on. So if you are seeing vesicular nuclei, that means you are inferring that there is going to be some nucleoli within the cell, and this cell is rapidly dividing. So most likely it is going to be malignant or a proliferative cell. So this is the classical vesicular nuclei with the prominent big eosinophilic nucleoli. The next type of cells that we see in histology, like these are the areas. So if you see these cells, these are very distinct from the cells that are seen here. So these cells, they are very hypochromatic. They are very dark stained as opposed to these cells which are lightly stained. So these are the hepatocytes which have got a vesicular nuclei, and in the vesicular nuclei you are seeing a nucleoli, and these are the normal actively dividing cells. So we have a vesicular nuclei here, and in addition you have these cells which are almost darkly stained, and in contrast to these cells, they have got a completely hypochromatic nuclei. So these are the cells which we are going to call as having hypochromatic nuclei. So when it is darkly stained, we call it hypochromatic. When it is lightly stained with the nucleoli, we call it as a vesicular nuclei. So again here to show you the same, so these are the epithelial cells and these are the vesicular cells, and if you look at the lymphocyte here, so this is showing a hypochromatic nuclei which is almost darkly stained. So if in a biopsy you have a problem in telling the nature of the nuclei, you can always look at the lymphocytes which are accompanying those cells, and based on the nature of the nuclei of the lymphocytes, you can tell the nature of the nuclei of the lesion that you are seeing. So you compare it with that, and then you can say that this is a hypochromatic or this is a vesicular nuclei. The third type of nuclei that we see on histology is a salt and pepper type of chromatin nuclei, in which it is all finely granular. So instead of one prominent nucleoli, many times you will see one or two nucleoli like in this case, but generally in these salt and pepper type of chromatin, most of the cases there won't be any nuclei, and there will be some finely scattered light areas and dark areas. Now this is distinct from the plasma cell cartwheel appearance that we have seen, where you see in a spoke-like fashion, you see the hypochromatic areas, and this salt and pepper appearance will be like that. So you mix salt with black pepper, finely granular, so that granular appearance is going to be seen. Now the importance of this type of granularity is when you're seeing tumors of neuroendocrine carcinomas. So if you see a cell which are almost uniform, like you see these 5 nuclei, they're almost uniform in shape, they're round, and you see a finely granular nuclei, then you call it as a neuroendocrine type of a lesion. So again, to recapitulate what we have discussed, so this is a plasma cell showing you the euchromatic and hypochromatic areas, and this is a cartwheel appearance. This is a vesicular nuclei, this is a hypochromatic nuclei, and these are the salt and pepper kind of a nuclei, which if you say that the cell is having a salt and pepper or finely granular chromatin, if you talk, then you are discussing about a neuroendocrine lesion. So that is about the different staining patterns of the nuclei. Then you have different patterns of nuclei. So if the different patterns of nuclei could be, the nuclei of the lesion could be all similar. Like if you see here, all these nuclei are looking similar to each other. So there is hardly any anisonucleosis. Anisonucleosis is the difference in the shape of the nuclei. So all of these are round to oval and they're almost of the equal shape. So this is called a uniform looking, monomorphic looking nuclei. And when you see a uniform looking nuclei, then you're talking mostly for the neuroendocrine carcinomas, or you're also talking of some lymphomas which also show you a monomorphic pattern. So this is a case of diffuse large B-cell lymphoma, and in this case again you see that there are sheets of cells which are looking similar to each other. So all the cells are looking similar to each other, and this kind of a pattern, we say that this is a monomorphic pattern of the nuclei when they all look similar to each other. Then this is the pattern in which we say that there is marked pleomorphism and an isonucleosis. So these nuclei, they are all very distinct, and some of them are very small, and there is no definite shape to this nuclei. So all of them, they are different. Some of them are round, some of them are very bizarre. So this is a markedly pleomorphic appearance of the nuclei. So this is not at all monomorphic that we had seen in the previous case. Now, at times the nuclei can come to the surface. So instead of being located at the basal part of the epithelium, they are seen on the surface of the epithelium, and this is called loss of polarity. Then sometimes the nuclei, they could be scalloped by the findings within the cytoplasm, like you have the vacuolation of the cytoplasm here, and it is indenting onto the nucleus. So you have a varied shape, and it is called as scalloped nuclei. Then at times the nucleus will show you an isonucleosis. So these shapes are different, but in addition these are very distinct apart, and they show a characteristic molding. So molding is when the nuclei are showing different shapes and sizes. So here it is like rectangular, here it is round. So these are all different types of nuclear molding that are being seen. And these, when you talk of nuclear molding, you are basically talking of a small cell carcinoma of the lung. So when we have discussed the nuclear features, so they could be monomorphic, they could be markedly pleomorphic, or they could be some anisonucleosis. Or at times they could show nuclear molding, where they could be molding of the nuclear membrane, and nuclear membrane can be irregular and different in the different nuclei. Now, the second thing that we are going to look at is at the cytoplasm of the cells. So the cytoplasm of the cells, if you see here, if you look at these cells, these are small lymphocytes, and there is a very thin, scanty rim of cytoplasm at the surrounding of the cell. If, as opposed to these histiocytes, which have got abundant cytoplasm. So if you are describing any cell, you are also going to tell, in addition to the nuclear features, you will tell about the degree of the cytoplasm it is containing, what is the amount of the cytoplasm. Then you are going to tell whether it is well defined or it is not well defined. You could not make out the boundary of the cell. So in this case, we will say that the cytoplasm is abundant. And why do we say that this is abundant? Because the amount of cytoplasm is more than the amount of the nucleus. So we say that this is abundant. So this is the nucleus, and this is the cytoplasm, which is much more than the nucleus size. So we call this as the abundant cytoplasm. Now the next is, like in this, we have a thin rim of cytoplasm, and it is very meager as opposed to this nucleus. So we say that there is a scant rim of cytoplasm, and in this there is a moderate amount of cytoplasm, which is almost equal to that of the nucleus. So in describing a cell, we are going to tell the nature of the nuclei, and then the nature of the cytoplasm, and how much is the cytoplasm, whether it is scanty, whether it is moderate, or it is abundant. So once we know the amount of the cytoplasm, then we are going to look into the cytoplasm. So we are going to look whether there are any changes in the cytoplasm. So if you see here, so these are the cells, and they have got an abundant cytoplasm, well delineated cell outlines, and most of these cytoplasm are showing fine vacuoles. So we will say that the cells are having abundant vacuolated cytoplasm, which is well defined. So this, again, you see most of the cells and nuclei are being pushed to the periphery, and the cytoplasm is filled with the finely vacuolated appearance. Now here again, this is a classical type of a feature that we describe on histology. So this is a signet ring appearance, and how do we say so? The nucleus here again is also pushed to the nuclei. The cytoplasm is the nucleus is eccentric. The cytoplasm is distended by a vacuole. Sometimes it could be a single vacuoles, but at times you could find 2 or 3 vacuoles. And in this signet ring appearance, you should be able to differentiate them from the foamy histiocytes. So how will you differentiate the foamy histiocytes? So if you look at the nuclei are very bland looking in the foamy histiocytes, whereas in cases of signet ring carcinomas, they will be hyperchromatic, and they will be seen at the side of the nuclei. So this is again a feature of the cytoplasm, and based on the nuclear features, you will be able to tell the type of the lesion. So whether it is a malignant lesion or it is a benign appearance. So again, these are again some signet ring cells, and in this you see that there is a vacuole in the cytoplasm, and this vacuole is beautifully seen here, and the nucleus is being pushed to the one side of the cell. Now this is another type of cytoplasmic inclusions, where the cytoplasm look almost clear. So there isn't any cytoplasmic hue, and it is looking completely clear. The cytoplasm could get cleared while processing, and these type of lesions we call it as having clear cell cytoplasm, and there is a differential for the lesions which show clear cell cytoplasm. So these are clear cell lesions, and the most common ones that we see are the clear cell renal cell carcinomas. So in most renal cell carcinomas, though the cytoplasm is finely granular, but when you process it on histology, the cytoplasm lose all its granularity and it will be appearing as a clear appearance of the cytoplasm. So this is a clear cytoplasm. Now the third type of cytoplasm, like we see here, so this is again a moderate amount of cytoplasm. It is eosinophilic, it is finely granular, and it is moderate in amount. It is ill defined, you cannot make out the cell boundaries. So this kind of a cytoplasm, when we see, this means that we are talking of some granularity. When we talk of in the cytoplasm, then most likely we are talking of some hormonal changes, or we are talking of the cell cytology, which cell histology, which belong to the endocrine organs. So in cases of all tissue or all epithelial cells which form hormones, you see some eosinophilic granular cytoplasm, indistinct eosinophilic granular cytoplasm. So in cases of medullary carcinomas of the thyroid, in cases of neuroendocrine carcinomas, in cases of pheochromocytomas, you will see cytoplasm like this. And then like for these cells, these are the cells which have elongated nuclei, which have blunt end, as you can see here. So there is no pointing at the ends, and here you cannot make out the cell boundaries. So though we know that the cytoplasm is intensely eosinophilic, we do not have a definite distinct cell boundary here, and here it merges with the surrounding cell. So now the next thing that we are going to look is at the type of cytoplasm. So here if you see, now these are the cells which have these vesicular nuclei, and the cytoplasm here is abundant and it is eosinophilic. Eosinophilic we say when they take up the eosin stain and they look pink or eosinophilic in color. So this is a reddish or orangish hue, and this is what we are going to call as a eosinophilic cytoplasm, as opposed to the cells which we are seeing in the background. Here they are showing an amphiphilic kind of a cytoplasm. Here we are the cells which are seen, we are not able to show whether to call them eosinophilic or to call them as basophilic. So this kind of a cytoplasm color we will call as amphiphilic, that is a mixture of blue and a mixture of eosin, that is pink color. So when you see a cytoplasm like this, we call it amphiphilic, and this is a beautiful eosinophilic color of the cytoplasm. So like if this is again another tumor in which you see that the cytoplasm of these cells are abundant, and this abundant cytoplasmic nature makes them called as oncocytic cell when they have abundant cytoplasm. So that is another nature, and that is another type of cell that we see, in which you have abundant eosinophilic cytoplasm, not that granular that we have seen in the endocrine organs. And this cytoplasm which is eosinophilic, as opposed to the cells that are seen in the background, they have a bluish cytoplasm. So these cytoplasm, they are basophilic, as opposed to this which is showing an abundant eosinophilic cytoplasm which is well defined. So now once we have discussed the histology, we have known the features of the nuclei and the cytoplasm, let us see some mimickers. So sometimes it is very difficult to differentiate how to fit that lesion into one category. So let us see how they mimic each other and how to differentiate them. So first let us see the spindle cell mimickers. So like I said, this is a cell. This is definitely a spindle cell, as we all can say. And in this cell, we could see that it has got an elongated nuclei, and the nuclei are blunt at one end. So they are not pointed, and they are showing like blunt ending, and their cytoplasm is indistinct and intensely eosinophilic. So there is a distinct type of spindle cell which is not as straight as we have seen at the previous one, but it shows some bend, or it will show some buckling, and that kind of spindle cells are the neural cells. So these are the neural cells where you see some buckling, some wavy-form nuclei. So here again the nucleus is going to be spindly, but that nucleus will show some bend in between, and this is a feature that we are going to look for in the neural spindle cells. Though you can definitely confirm them by doing an immunostains, but still on histology, by seeing these wavy appearance, we can say that these are the neural kind of a tissue where the spindle cells belong to the nerve endings. Whereas the previous one in which you see blunt end, they most likely belong to a smooth muscle, that is leiomyomatous cells. But this is not always true, as this is a case where you are seeing a fibrocyte. So fibrocytes will also show you little wavy appearance, but they will not be as wavy as we have seen in the neural tissue. So neural tissue is going to be very wavy in appearance, whereas the fibroblasts, though they are also spindle, they show tapering ends, that is, they are pointed at each ends, and they show little wavy appearance. So the next one is what is classically described in the literature is a cigar-shaped nuclei. And when we talk of cigar-shaped nuclei, we are actually talking of a smooth muscle cells which have got a blunt end at the ends, as we had already previously discussed. So these are the cells which are showing these elongated plump nuclei. Plump is, we will say, when they are like thick nuclei. These are thick, they are vesicular nuclei, and they are blunt at each end. So these are most likely the smooth muscle cell, and they have got abundant eosinophilic cytoplasm, as opposed to the cells which you see here. So these are little wavy, they have little cytoplasm. The cytoplasm is not as eosinophilic as we see on the top. So these ones are the muscle cell, and these ones are the fibrocytes. And fibrocytes, now we know, they are responsible for the production of collagen, and they are the supporting tissue, whereas muscle cells, they are distinct cells, and they are basically running in the different organs of the body to again provide them support. So these, if you have blunt nuclei, plump nuclei, abundant eosinophilic cytoplasm, then these are most likely the smooth muscle cells. But if you have little wavy nuclei, scanty cytoplasm, less eosinophilic, then these are the fibrocytes. So again, this is atypical smooth muscle nuclei, in which you see they are more enlarged, more pleomorphic, but the nuclei, if you see, they are bent at each the end. So this is from a case of a leiomyosarcoma. Now, sometimes in the epithelial cells also, or at times when you see large cells infiltrating any organs, it is difficult to put them into certain categories, whether they really belong to epithelial cells, or it is some poorly differentiated carcinoma, or it is a lymphoma. So at times they could mimic any lymphoma, they could mimic a melanoma also. And in those cases, what you are going to look for is, you are going to hunt for the glandular appearance, you are going to hunt for the intracytoplasmic vacuoles. And if you find these intracytoplasmic vacuoles, you find some mucin in them, you can call them as a poorly differentiated carcinoma. Otherwise, you will just call them as a poorly differentiated malignant neoplasm, if you are not able to ascertain from the cell shape or from the cell nuclei what different category it belongs to, whether it belongs to an epithelial, mesenchymal, lymphoid, or a melanoma. So in those cases, it is better to call them as a poorly differentiated malignant neoplasm, and then you can advise them for ISC for further categorization. But if in cases you find these vacuoles, you find mucin somewhere, then in those cases you can still call them as a poorly differentiated carcinoma, but in those cases also you will advise in IFC for confirmation. So now the next thing that comes when we see histology after the nucleus and the cytoplasm, the next thing is the cell size, and this is very important when we will discuss more about it when we'll discuss lymphoid organs and other neuroendocrine tumor. So what is small and what is large? So at times they will say that if they are large nuclei, you call them as a large cell lymphoma, and if the nuclei are small, you call them as a small cell lymphoma. But it becomes very difficult at times to categorize the lesion into a large cell or a small cell. So how will I say that this is a small cell, and how will I say that this is a large cell? So the thing that you're going to look for, again, as I said, you're going to look for these things, and these things you're going to find everywhere in all your slides are the lymphocytes. So go and hunt for these small lymphocytes, and when you find one lymphocyte, then you compare the rest of the things with this lymphocyte, and then you will be able to tell whether the thing you are dealing with is a small or large. So suppose this is a small lymphocyte, and in this lymphocyte you will compare this cell. So this cell is absolutely more than twice the size of this small lymphocyte, and you can fit these two into this easily. So if you have a cell which is more than 2 times the size of a lymphocyte, then you say that they are large cells. Ideally they are 4 to 5 times larger than the small lymphocyte. And if you see a predominant population of cells like this, like in this case, most of these cells are larger than this small lymphocyte, then you call it as a large cell lesion or a large cell lymphoma. So again, this is another case. So this again, what we are going to look for is we are going to hunt for these cells, and we could find them by their hypochromatic nuclei and small size. So this is a small lymphocyte, and then in this lesion again, I'm going to look whether the cells which I'm looking at, they are larger or they are smaller than this, and I'm going to fit this lymphocyte into this nuclei, and I will see how many lymphocytes can fit into this. So in this case, we could see that in this nuclei I could fit easily 3 lymphocytes. So definitely the cells that we are seeing, they are having a large cell appearance as opposed to the cells which are smaller, and the smaller ones are these small lymphocytes. The second thing that you can always compare your large cells is with the histiocyte. So one is your lymphocyte and second is your histiocytes if you are looking at a lymph node. So if you have a histiocyte in hand, you can compare the size of the nuclei with the histiocyte, and if they are equivalent, then also you can say that the size of the cell is larger or it is smaller. Now, once we have known the types of nuclei, we have known the types of cytoplasm, we are able to describe them in the slide, and then we know the different types of tissue that we have seen. The next thing that is important is the mitosis. Again, in mitosis has gained a lot of importance when we want to classify benign from the malignant lesion. So sometimes you will see mitosis even in a benign lesion. So you should be aware when to call this as atypical and when to say that this do not belong to the area where it should have been multiplying. So like see, we have a mitosis, and we all know that from our previous UG studies that mitosis has 4 phases: prophase, metaphase, anaphase, and telophase. So what happens is that these chromosomes, they come and align in the center, they just come together in the center, then they align in the center in metaphase, then in anaphase they move apart, in telophase they are distinctively 2 cells could be seen. So prophase is when your chromosomes are coming in the center like this, or they could be coming together but they are not properly aligned. So these are all prophase. Now any mitosis that you will see on your slide will be hypochromatic as opposed to these cells which are seen in the background. So these kind of mitosis are normal mitosis, they just mean that the cell is dividing. Then we have the metaphase where all these chromosomes are aligned in the center, and most often in all your malignant lesion you will see a large number of mitosis in the metaphase where the nuclei are aligned in the center. So this is very common. Then in anaphase they move apart, so you have a cell in which these mitosis are moving apart, and then in telophase you see that they have reached to the poles and finally they are going to divide. So these are the different kinds of mitosis, and these are the normal forms of mitosis which could be even seen on a benign lesion. But sometimes you will see mitosis which are atypical. So when to say that these are atypical and then these do not belong to the normal dividing cell? So when they assume shapes which are not normal to that location, like if you have a tripolar mitosis, so instead of your 2 poles which should have been formed, here you see that the cell is being divided into 3 poles, and at times it could be in the form of a ring. So this was also not expected for a normal benign mitosis, and at times they are so bizarre that you could not really put them into a different phase. So like this could be assumed as a dinosaur sitting. So this is a distinct type of mitosis, and they're all atypical mitosis that we see. So if you are finding any atypical mitosis, that means the lesion you are seeing is going in favor of a malignant neoplasm rather than a benign neoplasm. So that was about the mitosis part. So again, to summarize this lecture, so in the last we would like to conclude with 7 gems in histopathology that we should always remember when we see any histology slide. Is first thing, any tissue that we see in the epithelium has no blood vessels. So in any organ that we will see, the epithelium will be supported by a connective tissue beneath, from which it will get the blood supply and it will get the nourishment. The epithelium rests mainly on the basement membrane, but as we go higher we will see in some areas it also has got a myoepithelial layer, and that is true specifically for the organs which have got a contractile function. So there is a special form of smooth muscles which will be laid down there, and that is myoepithelium. But in most other areas epithelium rests directly on the basement membrane. Then neurovascular bundle lies in the connective tissue which is beneath the epithelium. It is important to identify the fibers in the connective tissue when we want to categorize the lesions, especially when we are going to categorize the different the soft tissue tumors. Then you should be able to tell whether it has got a blunt nuclei, whether it is more wavy, it is less wavy, and it is being accompanied by collagen fibers, or what kind of a matrix it is being accompanied by, so that you can tell whether it is a leiomyoma or it is something else. Now, atypical mitosis could have more than 2 poles. So you could have 4 poles. It could be Y-shaped, X-shaped, or it could be of any abnormal shape. So, but the number of poles are going to be more than 2. So it could be 3, 4, 5, or any number of poles that you can see. So all those will come into atypical mitosis. Large cells, you can compare them with the histiocytes, or you can compare them with the lymphocyte that is there in the vicinity. And then when you know the nature, the size of the cells, you can tell whether it is large or it is small. And if you find any atypical mitosis, that is the defining feature for the malignancy there. So with this, we conclude the second basic lecture of histopathology. And in the next lecture, we are going to run through some of the live slides. In those slides, we'll be discussing the different patterns that we had discussed, the description of the slides that we have discussed so far, and then we will see how we are going to approach the slides in real. So thank you so much. Thank you for your patient hearing.